On the introduction video, you might have noticed that I had a little extra circuitry under register C that is directly connected to the ALU. And that's this part of the circuit here. That's an improvement of the zero flag. The way I had implemented it firstly, I didn't have really a zero flag detector. I was just using the compare function of the ALU, and and to detect a zero I would have to compare any of the registers to register B when I had a zero stored into register B. And the compare instruction also is handy to compare, well, anything to anything as long as they're the same. The zero flag would then be activated. But while I was writing some programs for this computer, I noticed that this is a major setback for detecting a plain and simple zero, because we would have to use two registers for that. So register B would have to be cleared to detect a zero in other registers, and that is doable, but not really good in terms of programming. So I decided to add this simple zero flag here detector hardware. It consists of 8 NOT OR gates that are connected together with these AND gates, and then ORed together with our zero flag that we had before, or compare flag, and then send back here to our flags register. And the way this works is, since we're dealing with NOT OR gates, the output of these gates is always 1, except when we have anything other than 0 on its inputs. So that's exactly what we wanted. When we have all zeros, the outputs are 1s, and we are ANDing 1s together and getting a 1 in the end. And whenever we have anything different than a 0 in any of the input bits here, we won't have a 1 on the output of any of these gates anymore, and so we also wouldn't have a 1 on the end of our detector here, and that's already what we needed to detect to make the zero flag. And these two transistors here are just a transistor OR gate. I didn't have a chip of OR chip, so I just made one OR gate of 2 transistors, and they are taking the compare output of the ALU that we already had, that was going directly to the zero flag here, and then we are ORing this together with this detector that we made, and it's this output that is going to the flags register. So, and that was the change I made, and made programming the computer much easier